Hello and welcome to part 1 of section 2.3, the algebra of functions. So when it comes to our functions that model data or any function that we have, they have a domain, stay with the equation, but most equations themselves do not specifically define the domain explicitly. In these cases, the domain, though, would be the largest set of real numbers for which our function f of x is a real number. For example, f of x is equal to 2 divided by x minus 4. The only time this is not a real number is when we divide by 0, which just means that x cannot be 4. Because if it was, we'd be dividing by 0, and that's not good. So in interval notation, that'll be written as negative infinity to 4, union 4 to infinity, surrounded by parentheses. For f of x is equal to the square root of x plus 1, underneath that square root can't be negative. It can be 0, just not negative. So because of that, we could start at 0 and continue on to infinity with a parenthesis around the infinity and a bracket around the 0. So unless we have it specified, the function's domain is the largest set of real numbers for which, as we just saw, the function is a real number. So we are excluding division by 0, taking the square root of a negative number, different aspects like that. So for example, the domain of f of x is equal to 6x plus 9. This is just a straight line, right? We could graph it and whatnot. Nothing is stopping us from having a particular value, such as dividing by a 0 or anything like that. So the domain here is going to be the all real numbers. So negative infinity, excuse me, negative infinity to positive infinity, surrounded by those parentheses. For the domain of the function, f of x is equal to 1 over x minus 13 plus 1 over x minus 3. Since we have the two fractions, we have to, include both when we're saying no division by 0. So that means there's only two numbers x cannot be, right? X can't be 3, and x can't be 13. Because of that, we're in an interval notation. This would be everything in parentheses. Negative infinity to 3, union 3 to 13, union 13 to infinity. So when it comes to these functions, we can combine them using different operations and then determine the domain of those new functions if we wanted to. So the sum f plus g of x is f of x plus g of x. The difference f minus g of x is f of x minus g of x. The product f times g of x is f of x times g of x. And the quotient f divided by g of x is f of x divided by g of x. Presuming, of course, that g of x is not just 0. Otherwise, we can't do that. So an example of this would be if we let f of x be 5x minus 2 and g of x be x minus 1. We first want to find f plus g of x. So from that last slide, f of x plus g of x. Based on the two functions, this would be 5x minus 2 plus x minus 1. And we could combine like terms there. The 5x and the x to make 6x, and the negative 2 and the negative 1 to make minus 3. So 6x minus 3 would be that particular function. And if we want to put 5 in for x, as we do down here, in this new addition problem, this would be 6 times 5 minus 3. And that just nicely makes 27. And so it's 30 minus 3. This is part 1 of this section 2.3 on these functions, and I will see you in the next part of it. Thank you.